So this particular problem is really just a polynomial in disguise. So let's go ahead and square both sides. So we'll get y squared is equal to 3y minus 2. So now we can subtract 3y and add 2 to both sides, and we get y squared minus 3y plus 2 must be equal to 0. Okay, so now we can just solve this like any other polynomial. So we have y squared minus 3y plus 2. Um, so we want two numbers to multiply together to give us 2 and add to give us negative 3. I'm thinking y minus 1, y minus 2 equals 0. All right, so that means that our two solutions are going to be y equals 1 or y equals 2. And you can do that by setting y minus 1 and y minus 2 equal to 0. I've done a few of those so far, so hopefully at this point you know how and why to do that. But one thing you do have to check is you have to make sure that each of these solutions is actually valid. So let's check and make sure y equals 1 is valid. If we have 3 times 1 minus 2, that's going to be just 1, so 3 minus 2, that's positive. I want to make sure everything underneath the square root here is positive, so that's solid. And then we have y equals 2, so 3 times 2 is 6, minus 2 is 4, that's positive, that's good as well. So that means our two solutions are y equals 1 or y equals 2. All right, so in this next set of questions, we're asked to solve the following equations using the quadratic formula. And if you recall, we have the quadratic formula is given by x equals negative b plus or minus the square root of b squared minus 4ac. This is all going to be over 2a. All right. So all we really have to do to solve this is identify each part here. So for this one, we have a is equal to 9, b is equal to negative 3, and c is equal to negative 1. And just plug everything in. So we have x is equal to negative b, so negative 3, plus or minus the square root of b squared, so negative 3 squared, minus 4 times a, which is 9, times c is negative 1. And this is all going to be over 2a, or 2 times 9. This is really a negative 3 is positive 3. So we have 3 plus or minus the square root of 9 minus 4 times 9. 4 times 9 is going to be 36 times negative 1. So this will actually be just plus 36 all over 18. So now we have 3 plus or minus the square root of 45 all over 18. Okay. And we can rewrite the square root of 45 as 3 plus or minus square root of 9 times the square root of 5 all over 18. Or we have 3 plus or minus 3 times the square root of 5 all over 18. Or this would really simplify. If we pull a 3 out, we'll end up with 1 plus or minus the square root of 5 all over 6. Okay, if you left it like this, I would still count that as correct, because I know on the homework they didn't always have you simplify it fully, but this is probably the more preferred way to do it. If you could simplify it all the way, that's usually the way to go. So, okay. So next we have 11x squared minus 5x is equal to negative 2. So remember, to use the quadratic formula, we have to set everything equal to 0. It has to be set equal to 0 to use it. If we don't have that, then we can't use the quadratic formula. So let's go ahead and add 2 to both sides here. So we'll have 11x squared minus 5x plus 2 is equal to 0. So that means that our quadratic formula, we have, for our quadratic formula, we'll have a equals 11, b equals -5, and c equals 2. So we'll have x equals negative b plus or minus the square root of b squared. I should probably write what b is. Negative 5 plus or minus the square root of b squared, so negative 5 squared minus 4 times a times c. Okay? And this is all going to be over 2 times a, so 2 times 11. So this will really be 3, or sorry, this will be 5. 5, so negative 5, that's positive 5, plus or minus the square root of 25 minus 4 times 11, that's 44, times 2, that's 88, so minus 88 all over 22. Or we have 5 plus or minus the square root of 25 minus 88. We have negative 63 all over 22. Okay. So then we have 5 plus or minus. We can now pull an I out of this one, so to speak. So we have the square root of 63I all over 22. Or we can write this as two separate numbers if you want. Either way is fine. So this is fine. We can leave it here if you'd like. Or I think you could simplify it if you'd like. We could think of this as 9 and 7, I think. Yeah, so we could do this as 5 plus or minus the square root of 9, square root of 7, all over 22 times I, which is 5 plus or minus 3 root 7 times I over 22. That would be a solution as well. So there we go. So for this next one, we want to perform the following operations. We're going to be adding, subtracting, multiplying, and dividing complex numbers. So here we have negative I plus 3 minus 2I. So all we do here is just add straight across. So we have negative I plus 3I minus 2I. So combine like terms. Actually, sorry, this is not 3I. This is just 3. So negative I plus 3 minus 2I. Negative I and negative 2I. So we have negative 3I plus 3. But typically, it's more customary to write the imaginary part second. So we'll have 3 minus 3I. Okay, so here, now all we have to do when we're subtracting two complex numbers, we want to make sure we distribute this negative. And we can do it like addition. So this will really be 5 plus 2I minus 3, if we distribute the negative, and then distribute the negative here. Then we have plus 6I. So 5 minus 3, that's 2. And then we have 2 plus 6I, that's plus 8I. Okay, simple enough. Now here, we have to multiply two complex numbers. So we have negative 2 plus 2I times negative 4 plus 7I. All right, so let's go ahead and just FOIL this like normal. So negative 2 times negative 4, that'll be positive 8. Negative 2 times 7I, that'll be minus 14I. Then we'll have 2I times negative 4, that'll be minus 8I. And then 2I times 7I, that'll be plus 14I squared. So let's combine like terms. So we have 8 minus 14I, then we have minus 8I. So that'll be minus 22I. 14I squared, that's going to be the same thing as 14 times negative 1. So really this is combining 8 and negative 14. So 8 minus 14. So that means we're going to have negative 6 minus 22I. All right, so next we have 1 over 4 plus 2i. So in order to write this so that we don't have any imaginary components in the denominator, we're going to multiply both sides of this by we're gonna multiply this by the conjugate of the denominator over itself. So we'll do negative 4 minus 2i over negative 4 minus 2i. Now the reason we do this, well, the reason we multiply it by the conjugate over itself is that if you multiply a complex number by its conjugate, it has the nice property that it will get rid of the imaginary components, okay? So then we're going to just have a whole number of some sort, or at least not a number with a imaginary part in the denominator, and we'll be left with any imaginary parts will be in the numerator, which is exactly what we're looking for. Okay, so, and again, this works because if you have negative 4 minus 2i over negative 4 minus 2i, that's a number over itself. That's just equal to 1. So we didn't actually do anything. We just multiplied it by 1 in a clever way. So the top, because we're multiplying it by 1, that's going to stay the same. So we'll have negative 4 minus 2i over, now we can just FOIL like normal. So we have negative 4 times negative 4, that's 16. Negative 4 times negative 2, that is going to be negative 2i, so that's plus 8i. Then we have 2i times negative 4, that's minus 8i, and 2i times negative 2i, that's going to be minus 4i squared. So this is really going to be negative 4 minus 2i over, well, these will disappear. So now we have 16 minus 4i squared. But this is really going to be plus 4 because we're really doing negative 4 times a negative 1. So 16 plus 4 should be over 20. Okay? And if we pull a 2 out here, we'll have negative 2 minus I over 2 times 10. These will cancel. And we'll get negative 2 minus I over 10. Okay. And if you want to write this, I guess if you wanted to write this as a proper complex number, we could have a negative 2 over 10. That'll be negative 1/5 minus 1 over 10 I. This next question asks, Alvin's age is 3 times Elga's age, and the sum of their ages is 80. Now we want to know what Elga's age is. Okay? So let's go ahead and assign some variables here. So we'll say that A is Alvin's age. Okay? And we'll say that E is Elga's age. Okay? So here we know that Alvin's age. Well, we know that Alvin's age is 3 times Elga's age. So A is equal to 3 times E. Okay, and we know that the sum of their ages is 80. So A plus E is equal to 80. But because we have A equal to 3 times E, we can substitute this in here. So we'll have 3E plus E is equal to 80. So we get 4E is equal to 80. We can divide both sides by 4, and we get that E is equal to 20. So we know that Elga's age is 20. That's your answer. Okay? And you want to check that if we say that we know Alvin's age is 3 times Elga's age, so 3 times 20 is 60, plus 20, that'll give us 80, and so everything checks out. So we know that Elga is 20 years old. Okay? Now let's take a look at this one, and then we'll stop here and do part 3. So now we want to look here. So we have to find the distance between the point E equals 1, 4, and L equals 2, 10. Okay, so these are your 2 points. So we know the distance formula is given by the square root of uh, y2 minus y1 squared plus x2 minus x1 squared. Okay? So, we can, decide which point is which, and we can plug in our points for each each value here. Okay, so if we say this is point 1 and this is point 2, again, it doesn't matter which one is point 1, which is point 2. You just have to be consistent with your x and y values. If we say that e is point 1 and L is point 2, that means x1 is going to be 1 and y1 is going to be 4. Then we'll have x2 is equal to 2, and we'll have y2 is equal to 10. All right, so now all we do is plug everything in here. So we'll have d is equal to the square root of y2 minus y1 squared. All right, so y2 minus y1, so we'll have 10 minus 4 squared plus, and then we'll have x2 minus x1, so 2 minus 1, so 2 minus 1 squared, or we'll have the square root of 6 squared plus 1 squared, or the square root of 36 plus 1, or the square root of 37. So we know the distance between these 2 points is the square root of 37.